Because you mentioned animal-based foods are rich in nutrients. And I think that's a very important point, because when people look at a piece of meat, they immediately think about protein. Well, I can, eat protein from my vegetables, for example, or protein from my lentils. We forget all the other vitamins and minerals actually included in that piece of meat. So let's talk about bioavailability, because I think that's an important point of be it macro or micronutrients, and compare it from meat or animal sourced foods and plants.
Perfect. So let's look at these one by one. Vitamin A. Vitamin A is retinol. Retinol does not exist in plants. So there is zero vitamin A in plants, nothing. Now, what we are told is vitamin A in plants is something called beta-carotene. But beta-carotene is not true vitamin A. So there is zero vitamin A in plants. Now, my mother used to tell me to eat my carrots when I was growing up for vitamin A because they're high in beta-carotene to help you see in the dark. And there is some truth in this in regards to retinol, but there is no retinol in a plant. So what needs to occur if we are consuming beta-carotene from plants? That beta-carotene needs to be acted upon by an enzyme called BCMO in order to convert it into retinol. But this action is incredibly inefficient. In fact, it will reduce the volume of beta-carotene by about 21 times, making the amount converted close to zero. So plants do not contain vitamin A. Animal proteins have an abundant amount of active retinol, which is true vitamin A. Vitamin B1, B2, B3, all incredibly low, trace amounts at best in plants. Niacin, B3, incredibly low. Pyridoxine, vitamin B6, very low in plants. Again, trace amounts. Folate, we do have in plants, which is B9, but we can get way more folate from an egg. Eggs are a fantastic source of folate. It's the same story when it comes to vitamin B7, incredibly low in plants, very high in animal proteins. Vitamin B12 does not exist in plants. Vitamin B12 does not exist in plants. True vitamin B12 is cobalamin, and we can only get this from animal proteins. So what we find is with somebody living a vegan lifestyle, for example, they'll thrive for long periods of time because they've removed processed foods. They've stopped eating takeaways. They're no longer smoking and drinking. And they're far more active. They tend to take up, meditation and yoga or running. And you find that this person thrives for many years. And then suddenly their vitamin B12 stores in the liver have been depleted. And now the problems start to occur because vitamin B12, as well as B6 and B3, are imperative for the production of our neurotransmitters. B9 also imperative for methylation, which we need to methylation is essential for life. We can't live without performing methylation. And we can't do these things efficiently without cobalamin or B12, which we can only find from animal proteins, which leads then to having to supplement. And unfortunately, some supplements with cobalamin are not true cobalamin. They're in the form of cyanocobalamin, which contains a cyanide molecule. So it becomes, the waters become incredibly muddied when we begin to start to look at, what is true vitamin A and true vitamin B and so on and so forth. All of these compounds are true in animal proteins. And then beyond the B vitamins, we've got vitamin C. So vitamin C is found in plants. Kale contains a lot more vitamin C. The issue with kale is that kale is also high in a compound called flavonoids. Now, flavonoids are known endocrine disruptors. So it blocks our body's ability to create our hormones. It competes for absorption. And it also blocks the absorption of vitamin C. So the flavonoids in there prevent the body from absorbing much of the vitamin C in there. Now, also, when the kale is cooked, that 92 becomes close to 20. So this amount is greatly reduced. Vitamin C can be found in animal proteins. So beef liver is a fantastic source of vitamin C. Even beef itself contains, I think, if you look at an average steak, for example, a 12-ounce steak, I think from by memory contains around 12 micrograms of vitamin C. I think it's micrograms, isn't it? But it's comparative to citrus fruits. There's a substantial amount found in animal proteins. Now, the argument would be is that fruits are very high in vitamin C. The issue is that if we consume vitamin C with glucose, vitamin C competes for absorption with glucose through the GLUT4 transporter. So on the cell, we have little transporters that the glucose needs to enter and vitamin C needs to enter. And if we have these compounds both competing, then they compete for absorption and far less of each is being absorbed. So this is the issue when we consume vitamin C with glucose. So the bioavailability from the vitamin C in meats becomes far higher because now we're no longer competing for absorption. So when we live a low-carb ketogenic lifestyle, the amount of vitamin C we need to consume is greatly reduced. So I don't consume plants or fruits. I don't suffer with scurvy. And we know this to be true because if we look at the Napoleonic War, they used to feed the dead horse meat to the soldiers who were suffering with scurvy to prevent it and to combat it. There's enough vitamin C in the animal proteins to do all of these wonderful things. And then we move on to vitamin D. Vitamin D is found in animal proteins. Vitamin D doesn't exist in plants. We can obtain all of the vitamin C, all of the vitamin D that we need from animal proteins. Yes, we can get it from the sun, and we need to be out in the sun. The sun is incredibly important. But for certain peoples who don't have access to sun all year round or for very short periods of time, we find that their vitamin D levels are incredibly high through eating animal fats and animal proteins because of this content of vitamin D found within. Vitamin E is found in plants, but again, we can find vitamin E in animal proteins. Vitamin K, we consume kale because it's apparently a good source of vitamin K. And I'm probably going to break some hearts with this one, but there is zero vitamin K in kale. There's no vitamin K in kale, not in human form. Kale contains vitamin K1. The human body needs vitamin K2. So yes, there's vitamin K, but the K in there isn't active. It's not bioavailable, as you say. So we need to convert K1 into K2. And again, it's so inefficient. That process converts very, very little. What else have we got? Creatine, choline, carnitine, carnosine, all of these which are essential. Carnitine, which we can only get from animal proteins, it's part of redox balance, which is how we combat oxidative stress. It's used in the production of neurotransmitters. It allows us to metabolize, burn fat. It's part of the carnitine shuttle. This is how we send fatty acids into beta oxidation. So we can't burn fat without the carnitine shuttle, for example. What else is there? We've got, I'm losing track of where we are now.
Taurine.
Taurine. Fantastic. Taurine, very high, particularly in red meats. Taurine is another compound that is required for metabolism, for example. We need taurine to allow us to digest our foods. That works synergistically with things like choline to aid with the digestion and absorption of nutrients. We need taurine to absorb the fats and the amino acids, and choline is another part of this in regards to the journey of the digestive process. Choline is essential. So choline, another compound that's found in eggs, it allows us to make neurotransmitters in the form of acetylcholine. It allows us to mobilize the bile to allow us to digest and absorb. So what happens with the bile is when we consume proteins and fats, the bile acts upon these molecules to emulsify them, which increases the surface area. So now our pancreatic enzymes have a larger surface area to go to work on those before it moves further on into the digestive process. All of these compounds are essential, and we can't get them from plants. And what we can find in plants are incredibly unbioavailable. Nuts and seeds, for example, when it comes to omega-3s, Nuts and seeds contain ALA. The human body needs EPA and DHA, episapentaenoic and docosahexaenoic. ALA is inactive in the human body in regards to bioavailability. We need to convert that ALA into EPA and DHA. And again, it's such a laborious process, close to zero is converted. So for omega-3s, we have our oily fish, salmon, mackerel is the best source, sardines. But we can also get omega-3s from beef. Beef contains omega-3s. Lamb, a fantastic source. Lamb fat contains like 10 times higher the amount of omega-3s than beef does. And consuming these omega-3s will also help us offset any omega-6s that we are over consuming, which living this lifestyle, we would be typically we'd be avoiding. And then we look at the amino acid profile. Proteins in plants are different to the proteins in animal proteins. They are far less bioavailable. So the amounts that are found in plants, for example, need to be consumed in far higher doses to achieve the same result. And as you rightly say, we look at protein as just being protein. When we think protein, we think of building muscle. But there are 18 to 20 common amino acids that help heal and repair every cell in the body. Only 3 of these ultimately help us directly build muscle. There are more involved in certain processes, but in regards to the activation of mTOR and things, for example, there are 3 there that are involved in that process. If we look at a cell, so let's take a cell, for example. Every cell in your body is made up of 70% water. So 70% of the weight of a cell is water. So now we're left with 30%. 18% of that 30%, so over half of what's left is protein. Then 5% is fat, and only 2% is polysaccharide or sugar. So our cells are made of protein and they're made of fat. Our DNA is made of proteins. So all of our DNA is made of proteins. And the way that so when we talk about protein synthesis, the nucleus of the cell contains DNA, and through a process called transcription, we will copy this strand, a specific strand of DNA, and then it will be sent from the nucleus to the ribosome within the cell, where it'll go through a process called translation, where it will read these amino acids that are on the cells to make other amino acids. So it will take specific codons within this strip of amino acids to build different proteins. So it goes through this system of translation where the body will make proteins from these specific amino acids, which is taken from DNA that it's copied. And it will do this for every cell in the body. So if it needs protein to help with digestion and metabolism, it'll make those. If it needs proteins to help combat a virus or infection, it will make those. If it needs proteins to send to the brain, it will make those. Quite literally, every cell in the body is made of protein. So when we look at protein as just being muscle, it goes far deeper than this. Every single cell is protein. So we need to look at protein or animal proteins from a different perspective. We need to look at the building blocks. These amino acids are the building blocks to every single cell within the body. Even bone is mineralized protein. Bone, the dry weight of bone is 40% protein. We can't build and repair bone without protein. Yes, we need calcium, but we also need sodium. So we use that sodium to send the calcium to the bone to repair and rebuild that bone. You can't reverse osteoporosis, for example, unless you increase your protein and salt. You can slow down degradation by taking a calcium supplement, because what happens in this occasion is that any usage for calcium comes from the supplement and it doesn't take it from the bone, or at least it takes less from the bone. But if we increase protein and we increase our sodium, we can heal and repair and rebuild bone. Bone, we need proteins, we need minerals, we need phosphate. And that's those are the predominating factors of bone. There are others involved, but those are the 3 or 4 that we need, including the salt and the calcium that we need to repair and rebuild bone. And it all comes back to these animal proteins. So we need to look at protein from a dietary perspective as being something completely different, because that is the building block. That piece of meat on your plate, or whether it could be cheese, it could be bacon, eggs, beef, chicken, whatever, sardines, mackerel, these are the building blocks of every cell within the body. So if we are devoid of protein, then we're never going to be able to heal and repair and rebuild every cell in the body. So protein is essential. So one of the things that I teach is to always prioritize your protein, and not just to build muscle, but to heal and repair every cell in the body. If we look at protein in nature comes with fat. So an egg contains protein and an egg contains fat, and almost equal ratios. So an egg, for example, depending on the size, 6 grams of protein to 5 grams of fat. And if we look at chicken breast with the skin on, and if we look at a piece of beef, nature provides us with this perfectly packaged present. It gives us everything we need, not just to survive, but thrive. And what do we do in our wisdom? We cut the fat off. We cut off the fat because we think fat makes us fat. Fat doesn't make us fat. Fat allows us to build and heal every cell in the body. It's imperative, as we said earlier, for all of these functions within the cell to allow us to heal and repair and build every cell in the body, create all of these. The brain is 60% saturated fat. The myelin sheath that sends the signals through the body is made of cholesterol. Every cell in your body is made of cholesterol. And these are things that are essential for life. So eat animal proteins as nature intended is the biggest takeaway I think I can give, to any of the viewers and the listeners.
And this is why people who usually start, people like me, who started with a low carbohydrate diet, and then you see the benefits, and then you go more strict, and then you go into ketogenic diet, and then you naturally lean towards carnivore. This is what happened to me. It just happened naturally because that's what my body started craving. I started craving animal proteins. And I was a vegetarian for 30 years, by the way. So that was the most difficult thing I did in my life. The first bite of bacon that I've ever put in my mouth. Chewing that, I was weeping at the table like a child. So, but I'm glad I did it. It doesn't also fat. We were talking about fat. Doesn't also fat help you synthesize protein better?
Yes. Yeah. No,
Because of this rabbit starvation diet, for example, right? If you're eating lean protein.
Exactly. So, I mean, the fats allow us fat. This is why nature provides us with protein and fat. So if we look at protein synthesis is increased with the co-ingestion of fat. This is why we want to eat the fat, because the amino acids are absorbed a lot better and more efficiently if we consume them with fat. It doesn't happen if we co-consume it with carbohydrate. So even from an athletic performance standpoint, we are told that we need carbohydrate to build muscle. Carbohydrate doesn't build muscle. It has zero impact on that muscle protein synthesis. But what does increase muscle protein synthesis is the co-ingestion of protein and fat. And as you rightly say, if we consume excessive amounts of lean protein, it leads to rabbit starvation. We can eat all the protein that we want. Unless we consume it with a fat, we will become emaciated and we will eventually become seriously unwell and die. So it's okay to eat lean cuts. And I do, I eat as nature intended. So, there are lean cuts on animals. Even cows have leaner cuts of beef. But never neglect the fats in the long run. So it's okay to have leaner days. If you want leaner cuts of meat one day, just be sure that the next day or the day after that we are consuming these natural fats. Natural fats are essential for life. We cannot live without them. Fat is our friend. And coming back to what we just said, the two predominators that make up the weight of every cell in the body and every animal for that matter is protein and fat.